Hello class, welcome to CSC 321 Advanced Level Programming Language C++. This is our third class. Today we are going to talk on variables. Why are we hearing the word variable for the first time? A variable is a portion of a computer memory that stores a value. A variable needs a name that identifies and distinguishes it. Variable name can be something like X, Y, Z, R, etc. The variable name can be any name with the exception of C++ keywords, such as the key++ reserved words like int, main, count, and many other. Okay? C++ identifier is a name used to identify a variable, function, class, module, and other user-defined item. There are some rules governing how you can declare a valid identifier or a valid variable. Now, let's look at these rules governing how we declare a variable. Number one, a sequence of one or more letters, digits, or underscore characters. What this one is telling us is that a variable or an identifier must contain a sequence of one or more letters. What we mean by letters here is any alphabet A to Z, either in uppercase or lowercase. Then digits refer to 0 to 9, any number. Then of course an underscore. The second one, spaces, punctuation marks, and symbol cannot be part of an identifier. When you are naming an identifier or any variable, it should not be separated with space. As well, you cannot use punctuation mark like question mark, comma, semicolon, and what have you. And of course, symbols cannot be part of an identifier. Then the third one, identifier shall always begin with a letter. Any alphabet A to Z, an identifier or a variable name must start with it. Perhaps identifiers can also begin with an underscore, but such identifiers are on most cases considered reserved for compiler-specific keywords or external identifiers. Yeah. The fourth one is saying that you can start an identifier or variable name with an underscore, but in most cases it's considered as reserved for compiler-specific keywords. We'll be seeing that and continue with the class. Then the fifth one, identifiers can be containing two successive underscore characters anywhere. You can have an underscore before a variable name or before an identifier or at the middle or anywhere as long as there is no space in between. That underscore character can be anywhere within the name of the variable or the name of the identifier. Then the sixth one, in no cases can identifier begin with a digit. You cannot start identifier with a number. Then the last one, the C++ language is case-sensitive language. That means that an identifier written in capital letters is not equivalent to another one with the same name but written in small letters. For example, the result variable in capital letters is not the same as the result variable in small letters or the result variable in title case. These are three different identifiers identifying three different variables. Should take note. Right, now let's look at these examples. Figure out which one is valid identifier or valid variable name and which one is not, based on the rules that we just mentioned. Let's take the first row, FCE students. Yeah, FCE students, that one valid identifier? Yeah, it's a valid variable name. Then the second one, FCE underscore student, that one valid. You can use an underscore when you are naming a variable. Yeah, that one is valid as well. Then the third one, FCE space student. That space makes it invalid. So whenever you are having variable name with space in between, such variable name is invalid. Now let's take the second row, employee record with underscore, that one is valid. Employee record, no space, that one also is valid. But employee space record, that one is invalid, just like in the previous one. Then look at the third one, provost FCE underscore provost FCE, then double underscore provost FCE. They are all valid. You can start. Yeah, just mention of it. Then look at the last one, to provost FCE main. You just mentioned that an identifier must begin with a letter, and of course it can start with an underscore. So this one is starting with a digit, so that makes it invalid. Then look at the last one now. Result 2 in capital letters, that one is valid. Result 2, the result is in small letters, this one is valid. The two of them are two different identifiers, they are not the same. Result 2 in caps and result 2 in small letters are valid identifiers, but they are different identifiers. Should take note because we might mention that C++ is case sensitive. Then the last one, result, comma, 2, semicolon, FCE dot get. We might mention that we don't use punctuation, special characters, symbols when you are naming a variable. So that makes this variable invalid. Right? Whenever you talk of variable, you can't go away with data type. That's the type of data that variable will hold. The values of a variable are stored in the computer memory as zeros and ones. The program needs to know the kind of data stored in the variable. It is not the same to store a simple integer as it is to store a letter or a large floating point number. Data types are not the same, and in many cases, they occupy different amount of memory space. Each of these data type has its own memory space depending on the type of the data. Okay, let's look at the different kinds of data type. Can mainly be classified into one character. For example, single character, something like D, G, Alt, A, C, etc. It is not represented in C++ as char, C-H-A-R. Whenever you want to declare a variable to be of data type character, it can accept just a single letter, maybe like your grade. Maybe you want user to type grade, maybe just a single letter, maybe whether he's called A or B or C, you can declare such variable to be of data type character. Then the next one, numerical integer. Yes, that one is dealing with whole numbers. Yeah, example is maybe something like 34, 56, etc. Like our ages. Yeah, mostly our age are in whole number. How old are you? You can just say I am 21.5 years old. No, just tell us you are either 21 or 22. Okay. Then integer, how it's been represented in C++ is int. Int. And the next one is floating point. Floating point normally used for real numbers, the decimal places, numbers with decimal place. They are normally used in the floating point. Something like 2.3, 56.8, 9.1. Like CGPA, for example. What is your CGPA? Maybe you are 4.5, maybe you are 3.5, things like that. So such variable are being declared to be float, and how it's being represented is just type float, that's float. Then the next one is boolean. Yes, when you are declaring a variable, yeah, that has to hold a decision, something like true or false, yes or no. Yeah, for example, are you married? The answer should be either yes or no. Okay. So such variables can be declared to be of type boolean. That's bool. The spelling is bool. Okay. Now let's look at the different categories of this variable. We just made mention of the character, the integer, and the floating point. If you take the character type, start like four different categories, like the car 16 underscore T, the car 32 underscore T, then the blue car underscore T. They fall under the categories of the character. If you are declaring a variable to be of data type character, it can belong to any of these. The most used one is the car. Car 16 stands for something, car 32 like that, and the blue car underscore T. Okay. Then the next one is integer types with the sign. Okay, like here we have the sign car, sign short int, sign int, sign long int, sign long int. Then the next one is the integer types on sign. The same thing with the previous one. The only difference is the sign and unsigned. Here we have the unsigned car, unsigned short int, unsigned int, unsigned long int, then unsigned long int. Then the next one is the floating point types. Under the floating point types, we have like three different categories. The float itself, that's the normal decimal that we are used to. Then the double, yeah, Then of course the long double when you are using sophisticated computation that requires using decimal places like in numerical analysis computation. Then of course we have the Boolean type that I mentioned earlier. It will be represented as the bool. Apart from that one, we also have the void type. It's going to be represented as void. Then the last one, but not the least in this category, is the null pointer. They represented as DECLTYPE. Then in bracket NULLPTR. That's for the null pointer. Next thing we're going to see is how we declare variable. Now that we know what a variable is, what a data type is, and different kinds of data types. So the next thing is how to declare this variable. C++ requires every variable to be declared with its types before its use. This informs the compiler the size to reserve in the memory for the variable and how to interpret its value. The syntax to declare a new variable in C++ is straightforward. We simply write the data type followed by the variable name or the identifier name, for example. Data type, then name of space, then name of variable. You just mention data type and mention how to name a variable. Now let's look at it. Look at this example. The first one is int school fees. What does that mean? We declare a variable with the name school fees and the data type of this variable is integer. So what is expecting this variable to hold is anything of type integer, nothing more than that. You know what an integer is, all numbers. Then the second one is float employee underscore pay. So employee underscore pay is the name of the variable or identifier and the data type of it is float. So we are expecting employee underscore pay to hold anything in decimal point like CGPA and the likes. Then the next one is int years. How old are you? You just give your years. Okay, that one should be in integer as well. I just made mention of it. So here, yes is declared to be of data type integer. Then the last one given in this example is car grade. Grade is declared to be of data type character. Of course, what is your score in C++? Yeah, I'm having A, I'm having B, I'm having C, All such kind of things should be declared as car. Okay. Still, on variable declaration, user can declare more than one variable of the same type. They can be declared in a single statement separating their identifiers with commas. For example, int school fees, int yes. They all have the same data type. What we need to do, just separate them with a comma. That's all. Now, let's look at this simple program that demonstrates variable declaration. You look at it. At the first beginning, the first line, line 1 is operating with variable. This one is just a comment. The second line, if you look at the comments, after the comment is an empty line. Then the third line is include IO stream. Can you see that? Then using namespaces std, then of course int main open and close bracket. Then this way the program starts. It begins. Also another comment declaring variables. Now you look at it. Int a comma b, then end of line semicolon, then int result. A comma b are declared to be of data type integer. Then the result also is declared to be of data type integer. So here, if you like, you can make all of them to be in the same line. Int should be written only once. Int a comma b comma result, the end of line. If you want, you can make all of them to be in each of them in a line. You can make it to be int a semicolon, int b semicolon, then int result semicolon. You have the liberty to choose whichever you want. Okay. Then look at the next comment is process. A is equal to 5, B equal to 2, A equal to A plus 1, the result equal to A minus B. Wow, that's the beauty of programming. You can see A equal to A plus 1. All right, yes. What does that mean? So in the first instance, A is equal to 5, then B is equal to 2. So now in line 15, if you look at it, A equal to A plus 1. Initially, the value of A is 5, right? Yeah, so now we are incrementing the value of A, that 5 plus 1. Now, our new value of A is going to be 6. 5 plus 1 is what? Is 6. Then the result is a minus b. Our a is already 6, so just 6 minus 2. The result of 6 minus 2 now it kept inside the variable with the name result. So look at the command that we use in printing out result. Print out the result. You see out, then result. Already our result is having 4. So terminating the program, you return 0, then you end. Then the result is going to be the value of result, and of course it's 4. Alright, let's look at this simple program now. Let us look at the program carefully and see how many errors we can find from this program. The first line operating with variables as a comment, then the hash include IO stream using namespace std as usual, int main, begin declaring variable. You look at it, float. Float is valid data type, of course. 2a, we don't start a variable name with anything digit like numbers. So here variable 2a is invalid. So that's one. B is valid, int result is valid. Look at the process, 2a equal to 5. 2a is invalid identifies invalid variable name, not even to talk of making assignment with it. B equal to 2, that one correct. 2a equal to 2a plus 1 is totally wrong. Result equal to 2a minus b is wrong. You'll be having compile error. Then print out the result, see out result. Yeah, that one may be right, but the computation above it is wrong. And then finally, when that terminating the program, you see return. Return what? The 0 there is missing. Okay, so basically how many errors we are having? In declaration, we are having 2a, 2a is an error. Okay, in the process, all the 2a's we are having, they are errors. Okay, then of course, the last one is the return, 0 is missing. Get it? Is initialization of variable. See like initialization data type. See like initialization have this format. Data type, identifier equal to initial value. For example, you start data type, then the name of the identifier, then your equal sign, then the initial value. Like in this case, int is the data type, x is the identifier, equal sign is here, then initial value is 0, then end of line semicolon. You can see it, easy. Okay, int x equal to 0. You initialize, you declare a variable and you initialize it at the same time. This initialization can be in two forms. It can be constructor initialization or uniform initialization. And the constructor initialization, it's written in this form, int x, then in bracket, you write what you want to initialize it. Even if it's 0, like in this case, you just write 0 inside the bracket. That's for constructor initialization. For uniform initialization, int x, then inside curly bracket, you have your 0 or whatsoever you want to initialize your variable x with. X can be any variable, okay? Let's look at this program that works on variable initialization. Can you see it? The first line is initialization of variables appearing as a comment. Then the hash symbol include IO stream using namespace std int main. Int a equal to 5. You can see that variable a is declared and is assigned to value of 5. Can you see that? Then the next one is int b 3. Then int c 2. Can you see that? Then int result. Now you look at it, a equal to a plus b. What the initial value of our a is 5, then the value of b, you can see, is 3. So it's going to be 5 plus 3, that's 8. Our a now is 8, then result equal to a minus c. Our a is 8, c is 2, is going to be 8 minus 2. And the result is assigned into a variable result. Now see out result. So our result, the final value is, final result is going to be 6. It's just 8 minus 2, which is 6. Get it right? Then is introduction to string. String variables are able to store sequences of characters such as words or sentences. Maybe you may be asked to write a program that accepts your name. Yeah, your name is not just an ordinary character, a single character, okay? It can be a sequence of characters. So in that case, we are working with string. The program needs to include the header where the type is defined within the standard library. Header, string. Whenever you want to work with string variable, you have to use the include string, and it must be declared before using a string. Normally it appears at the beginning of the program, and the format is include string. Now let's look at this program that demonstrates how to use string. The first line, you can see my first string. After the hash include IO stream, the next one is hash include string, meaning that we are going to work with a string. So now the string is now added to the library. Now you can see using namespace std int main. So now you can see a string is declared. String is a data type. Then the name of the variable is my string. It's just like integer, the name of the variable int, the name of the variable my int. It's just the same. Or car, the name of the variable my car. That's exactly what happened here. So now my string is assigned to this is a string. You can see this is a string is enclosed with the double quotation. And of course, it's more than one character. It's a sequence of characters. Okay? Then see out my string. My string is containing this sequence of characters. This is a string. Then return 0. Of course, when you run this program, what are you going to see? This is a string. Next one are constants. Constant are expression that has fixed value. They have their own form. When you want to declare a constant, you normally start with the const keyword, the data type, the name of the constant, then the equal sign, then the literals. For example here, const double pi equal to 3.1415926 semicolon, or const car equal to single quote backward slash t backward single quote then end of line semicolon. That's how constant types are declared. Instead of you to be typing 3.1415926, you just type pi. It saves time. Look at this program that demonstrates how you work with constant. Include IO stream using namespace std. Now you see const double pi equal to 3.14159 and end of line semicolon. Now pi is assigned to be 3.14159. Instead of you in the program to be typing 3.14159, you just be typing pi. Okay. Then const char new line. Instead of you want to go to the new line, okay, new line is assigned to semi inverted comma backward slash n, then backward slash the end of line. What this one is doing is that whenever you type this semicolon, whenever you type this single quotation, backward slash n and single quotation, it will take you to the new line. So instead of you to be typing this one, just type new line, you assign it to this one. Whenever you type new line, you know that it will bring a new line for you. Okay, just the same thing with the pi. Now let's look at the program where int main begin double r equal to 5.0. You see? Then double cycle. Cycle is declared as variable and is not initialized. But here cycle is initialized to be equal to 2 times pi times r. We know what is our pi. Pi is declared to be constant. Yeah. Then times r. R is declared and initialized and is 5. Then see out. What's going to be the cycle now? It's 2 times 3.14159 times 5.0. Okay, then that's going to be 31.4159. Then see out new line. Then the cursor move to the new line. That's all. Literals. Literal are used to express particular values within the source code of a program, to give specific values to a variable, or to express messages we wanted our program to print out when we write. For example, a equal to 5. The 5 is the literal constant. Maybe x equal to 2. The 2 is literal constant. Pi equal to 3.14159. These 3.14159, they are the literal constant. Okay, then another one, we can have character constant, we can have string, we can have character literals, and of course we can have string literals. For character literals, something like z or p. If it is a single character, it will be enclosed within a single quotation. But if it is a string, it will be enclosed within the double quotation. That's why in this example, you can see hello world is enclosed within the double quotation. How do you do? It's enclosed within the double quotation. But Z and P are enclosed within the single quotation because they are just characters. Should take note. Okay. All right. The next one is the preprocessor definition. The preprocessor definition is another mechanism to name constant values. It's the use of preprocessor definition. And the general format is the hash sign, define, identifier, then replacement. Hash sign is fixed, must be there, define must be there, then the name of the identifier, then of course the replacement will follow. After this directive, any occurrence of an identifier in the code is interpreted as replacement. That is any sequence of characters. Note that the hash defined lines are preprocessor directives and as such do not require semicolon at the end. A simple program that demonstrates the preprocessor's definitions. You look at it. Include the IO stream using namespace std. Now, let's see define. Hash define pi 3.14159. Can you see? Then the next one, hash define new line, single quotation backward slash n, then another single quotation. Not any end of line as you just mentioned. Okay, so it has the same explanation with the constant. This one you use preprocessor directive. In the constant, you have the end of line, semicolon, this one you don't need. In the constant, you have the assignment operator, equal sign, here you don't need it. Okay, so whichever one you are familiar with, you can make use of it. Now you see int main begin double r equal to 5.0 double cycle. Then cycle now is assigned to be 2 times pi times r. Pi is already declared as preprocessor directive and is 3.14159. Then our r is just declared here and initialized as 5.0. So when you multiply the two variables with the literal, you end up getting 31.415. The same thing with the previous one under constant. Then see out new line. We'll move the cursor to the next line. This we come to the end of today's class. Thank you for listening.